Is my screen visible to you all?
Yes, sir.
Okay, so we will start from where we have left. So in today's class, but before I start today's class, do you guys have any queries, any doubt from the earlier classes? Hiram, Anna, Abhinav?
No,
Any?
sir.
Okay. Okay. So hello, Arpit. Hi.
Good evening, sir.
Good evening. Good evening. Okay. So yes. So in today's class, we will be studying about the relative motion as the topic suggests. And the second one will be the uniform circular motion. Okay. But before I do that, let's do a quick revision of motion in 2D, right? So only the 2D part. So if you have a moving body in a plane, right? So this board is a plane where you have two coordinates, right? So this is X coordinate, this is Y coordinate, and some vector or some body is moving in this direction. So it is moving in the X direction as well as the Y direction, right? So that is how the motion is in 2D, right? Okay. So this velocity will have X part, X component, and the Y part. That is how you break the vectors, right? So this velocity will have two parts, right? Okay. And can you guys recall what was the cross product? Hiram, Arpit, Abhinav. Hello. So the cross product of two vectors was like this, right? We used some determinant method or the cyclic property of the universal unit vectors, right? So your universal vectors, unit vectors were what? I and j. And if you have a 3D motion, then I, j, and k were universal unit vectors, right? So before I do the relative motion, let's just do a question to memorize or to revise the vector part. Okay. Okay, so three particles P, Q, and R are moving along the vectors A, okay, and B and C, right? So P is moving along A vector, and Q is moving along B vector, right? And R is moving along C vector. Okay. And if I want to draw a normal for A and B, right? So what would be the normal for A and B? Can you guys remember the vector classes? Iram, if I want to draw a vector which is normal to A and B, so let's just give you a hint. So let's say you have a I vector, right? And you have a J vector, right? So if you want to make a vector which is normal to this I and J, so what do you do? Which is both perpendicular to I and J. Normal meaning both perpendicular to A and B. Can you guys recall? Arpit, Abhinav, Heather, Iram, Anna, Sanya. Oh, Sanya, first class. Okay, so Do you guys remember? So can you guys tell me that what will be the vector which is both perpendicular to I hat and j hat? What is a vector which is both perpendicular to I and j? So let's just say that this vector I and j in a plane on a board, and you are going out of the board or into the board, two directions. So what will be the third vector?
A cap.
Which is,
K cap.
yes, k cap. So k cap, right? So this k cap is mutually perpendicular to I and j, right? Remember? Remember? And how do you get k cap? You cross multiply I and j. Then you get k, right? So that is how you get a normal vector both perpendicular to I and j, right? So did you guys forget the vector classes? Huh? Okay, so is this clear?
Yes, sir.
So understood the point that if you want to draw a normal which is both perpendicular to I and j, then what you do? You take the cross product, right? Understood. This is the idea. Okay. So now let's just get back to this question that they are saying that yes. So A, B, C, respectively, they strike on a point and start to move in different directions. Okay, so they come close and they strike and they go different directions. They collide and they go different directions. Okay, now particle P is moving normal to the plane which contains vector A and B, right? So normal to this and this. So what we will take? What will be the vector which is normal to A vector and B vector? What will be the vector? I just gave you the idea recently, just a moment ago. So that will be the P will be what? A cross B, right? Right. So this will be like a revision of your vector classes. So that's why I chose this question. Remember, so is this correct? A cross B will be normal to A and B.
Sir, the
Is this
C will
correct?
be multiplied.
Why would the C would be multiplied? Because this A cross B is normal to A and B only, na? So they are asking about plane which contains vector A and B, right? Only A and B. So if we take A cross B, that will be normal to A and B, right? So let's just remember again. So this is I and this is J. Okay, so P is moving normal. So this is normal. So P is normal to A and B, right? So P vector is normal to A and B, right? So that's why we took the cross product of A and B. Understood?
Yes, sir.
Any? Okay. Now what will be the Q vector, which is moving normal to the plane which contains vector A and C? So what will be the Q vector? Tell me. Which contains vector A and C and which is normal to A and C. So what will be the Q vector?
A cross C.
Yes, A cross C, right. So A cross C will be the Q vector. Okay, so this is the first information, this is the second information, right? And now the third information that we have to apply. So the angle between the direction of motion of P and Q. Okay, right. So let's just first calculate P vector. So P vector will be what? I plus J cross J cross K. Right. And if you want to use the matrix multiplication, use that, or let's just use the cyclic property. So I, J, and K. Right. So I cross J will be what? I cross J will be Iram. I cross J will be what? Arpit, I cross J will be K. Yes, K vector, right? And I cross K. So I cross K will be what? Minus.
Minus.
Yes, minus. Right. Minus J. And J cross J will be 0. And J cross K. J cross K will be what? Plus or minus I?
Plus.
Yes, right. So this is what? This is I minus J plus K. Right. So we calculated vector P, which is I minus J plus K. Okay. And what will be vector Q? This will be what? A cross C. So A cross C. So Sanya and what was your name? Umra. Sorry, Namra. Did you get the point?
Yes, sir. Kind of.
Okay. So I cross I will be what?
0. 0.
Right. And I cross J will be K.
K.
And J cross, yes, J cross I will be minus and minus will be plus. So this will be K. Right. And J cross J will be again 0. Right. So this is 2K hat. Understood? Any doubt? Okay, nice. So now we have calculated P vector, right? And we have calculated Q vector. Okay. And now the angle between the direction of motion P is then the value of X. So what will be the angle between P and Q? Can you recall the dot product? If you know the vectors in the universal vector form, right? So we can calculate the direction using the dot product. Remember? Am I making any sense? Is that correct?
Yes, sir.
Okay. So what was P dot Q? Hiram, what was P dot Q?
0.
It was P. It was,
Oh, it is constant.
yes, this is not perpendicular. Na? P and Q are not perpendicular. So cos theta. If cos theta would have been 0, then this would have been a 0 because P and Q are not orthogonal or perpendicular, right?
Yes, sir.
We don't know that if these are perpendicular or not. So that's why we can't say that they are 0. Dot product is 0. Okay. So what will be P dot Q? Let's just calculate from here. So all the other will be 0 only. K dot K will survive, right?
Yes.
Right. So this will be what? 2. Okay. And magnitude of P will be what? Right. and magnitude of Q is already given. So this is right. Am I correct?
Yes, sir.
So this is root 3 and this is 2 and this is cos theta, right? So cos what? So cos 2 cancel. Cos theta is 1 by root 3, right? So theta is what?
60 degree.
No, no, no. Why? Because 60 is 1 by 2. This is not 1 by 2, right? So this is theta is cos inverse 1 by root 3, right? Right? Right, na?
Yes.
Now let's just compare this with this direction. Okay, so they are saying that the direction found out to be cos inverse 1 by root of x, right? So this theta is equals to cos inverse 1 by root x, and we have to find the x value, right? So let's just compare these two. So cos inverse 1 by root 3 is cos inverse 1 by root x, right? So this cancels. So root 3 is root x. So x is 3, right? Understood?
Yes.
Okay. So now let's just do the relative motion. Okay. So what is a relative motion? So if two bodies are moving, right? So let's say this is a velocity, a body A is moving with velocity VA, and some other body is moving with some other velocity VB. So V velocity of A with respect to B is called, this is called the relative velocity, right? And this is equals to what? This is equals to VA minus B. Okay. So if both are coming in the same direction, then this will be both are going in the same direction. Okay. So this is VB and this is VA, right? So they will see that relatively, they will see that the velocity is smaller or velocity is decreased. Why? Because VB minus VA will be a smaller value, right? Let's just say that two trains are moving, right? And they are going in the same direction. Okay. So if train 1 is moving with 100 kilometer per hour and train B is moving with, let's say, 50 or 80 kilometer per hour, then relatively what you will see that train is going with 20 kilometer per hour, right? If they are going in the same direction. Understood? This is called the relative velocity. Or let's just say that they are moving in the opposite direction. So train is moving with 100 kilometer per hour in one direction, and oppositely train B is moving with 50 kilometer per hour. So the relative motion will be what? The relative velocity will be 150 kilometer per hour. Understood? Any doubt, any query?
No, sir.
Okay. So there are two cases for relative motion in 2D. Two cases for relative motion in 2D. One will be that the medium will be moving along with the object. So the object is in the medium, right? and object is moving along with the medium, right? So let's just say, so some example of this is what? That the river problem. That you are crossing a river, right? So this is one example of when your medium is moving and the object is in the medium. So, Heather, did you got disconnected at some point?
No, sir, I'm joining from another device.
Okay. So one example is what? River problem, where your medium is what? River. So river is flowing and the object is crossing the river. So this is the one example, and one is the when your wind problem. Okay. So wind is flowing and somebody or airplane is moving in the wind. Okay. So that is the second example of object in the medium. So this is the first case. And the second case is what? That both the objects are moving. Okay. So one problem is the rain problem, rain man problem. Okay. And the second problem is that one body is going like this and second body is going like this. Okay. So this one is called the distance of closest approach, but I will leave that distance of closest approach. Okay. So always remember that in this case, always. So this is sometimes very confusing, but you have to remember only one thing, that for this first case, you apply, okay. So for the first case, you apply the addition of vectors. Or the resultant vectors. Okay. For the first case. And for the rain man problem or the distance of closest approach, you apply the subtraction of vectors that we have studied in the vector classes, or the what? Relative velocity. Right. So this is the main theme when you solve the river problem or the wind problem, or you solve the rainman problem or the distance of closest approach. Okay. So let me just give you some examples of that. So let's just say that first one is the river problem. Okay. So let's just say that river is flowing this way. Okay. So this is the velocity of the river. Let's just say that. And the man is crossing this river like this. So this is the velocity of the man. Okay. So we have to apply the resultant method, the resultant approach. So what we will do that, we will take this river here. So this is the VR, and we will calculate the resultant, right? Understood?
Yes, sir.
So this will be the resultant of this vector. So this will be the net velocity. Understood? So this is called the drift velocity. The man wanted to cross the river like this way, but he got drifted because of the horizontal. This is the horizontal velocity. And this is the what? Vertical velocity. So the man got drifted this much, right? So this is how you solve the river problem. Okay. Understood? So V net will be what? V net will be VR plus VM. And the magnitude will be what? VR square plus VM square. Okay. And what will be the angle with this horizontal? So this is this angle will be what? Tan theta will be what? This is P. So VR and this is M. Right. Understood? Any doubt?
No, sir.
So one can also use this approach that the velocity of the river will be like what? So velocity of the river will be some VI hat. Okay. Understood?
Yes.
And velocity of the man would be what? Some, let's say VM J hat. Okay. And net will be what? VRI plus VMJ. Right. Okay. So with the horizontal, the angle will be what? So this will be what? So for the horizontal, this will be what? VM by VR. Whatever the angle they ask. Okay, so if they ask with the horizontal, so this will be the angle, the vertical. And if they ask with the horizontal, so this will be the angle. You apply the vector law, right? Now in the second part of this question, the river problem, you remember that the man started from here, right? And he moved like this. But resultantly, he got carried away by the flow of the river, and the resultant was this, right? Right, na?
Yes, sir.
But what if the man wants to complete his journey or wants to cross the river in the shortest path? So what if he wants to travel in the shortest path? So what is the shortest path between, let's just say, so this is the width of the river, right? And he starts from here. Okay. So if he wants to travel in the shortest path, so what will be the shortest path from this to this point? Is it this one, this one, this one? What will be the shortest path? A, B. So there's the straight line one, right? Na? So this one, A1. So this is the shortest path, right? And the river is flowing like this. Okay, so he should start with what? Some angle like this way, right? So that his resultant will be like this, right? So this is how he start crossing the river, so that the resultant V net is like this. Okay, so this is the velocity of the man. And this is what? Velocity of the river. Understood my point?
Yes, sir.
And now just let's just remember one trick that is very useful. Okay, so let's just remember one right angle property. Okay, so you have this base is 3, right? And the perpendicular is 5. So hypotenuse will be what? 5. Okay, understood? And the angle that is opposite to 3 is what? 37 degrees, right? And the angle opposite to the 4 one is what? 53 degrees. So remember this one, this triangle. Okay, it is very handy in some calculations. So understood? Any doubt? Any doubt? Do you guys have any doubt? Any query?
No,
Okay.
sir.
Okay, so let's just do some question based on that. That will make it more clear. Okay, so let me just drop this much. Were you guys noting down anything, or do you take the screenshot, or what you just remember? What do you guys do?
No,
Screenshot.
down.
Okay. So tell me that you have not noted down, then I will pause, or if I am moving very fast, then just tell me. Okay, so this one. Okay, so the speed of a swimmer in still water is 20 meter per second. You have to remember only 2 points, right? For the river problem or for the wind problem, whenever you are in a medium, right, you have to apply the resultant formula. Just remember this. And when you have a rain problem or the two bodies coming along with some directions, both are moving, then you have to apply the relative velocity or the subtraction of the vectors. Understood? Just recall these 2 points. Okay. So the speed of a swimmer in still water is 20 meter per second, right? Along the shortest path. So the speed of river water is 10 meter per second and is flowing due east. Okay, so let's just make this one. So, okay, so the river is, so where was I? The speed of a swimmer in still water is 20 meter per second, right? And the speed of river water is 10 meter per second and is flowing due east. So this is how the river is flowing, right? Okay. And if he is standing on the south bank and wishes to cross the river along the shortest path, so this is the resultant. So this is V net, right? And if he is standing, wishes to cross the river along the shortest path, the angle at which he should make his stroke with respect to north is given by, right? So he is making some angle with respect to north, right? So this is the velocity of the man. The first part is making the diagram. Okay. Understood?
Yes, sir.
So this is VR, right? Okay. And this is given 20 meter per second, right? So this is given 20 meter per second. This is 10 meter per second. And we have to find this angle, right? Understood? So let's just draw this diagram here. So this is theta this is 20, this is 10. Okay, so this is what? This is the hypotenuse, this is the perpendicular, right? So what trigonometric identity we will use? First part is clear, na? The diagram is clear, right? Do you guys have any doubt about the diagram? Am I audible? Arpit?
Yes, sir.
So the diagram part is clear, na?
Yes, sir.
Yes, sir.
Okay, so to calculate the theta, what trigonometric identity we should use? Arpit? Sin theta, na?
Yes.
So this is sin theta is P is what? 10 and this is 20. So sin theta is half. So for what value of sin theta? Theta is half. So theta will be what? Theta will be? Heather, theta will be what? Sorry? Irem, what will be theta? For what? 30, right? So sin 30 is half, right? So this is the answer. Okay. Now let us move on to the next question. So this one. So a butterfly is flying with a velocity 4√2 meter per second in northeast direction, and wind is slowly blowing at 1 meter per second from north to south. The resultant displacement of the butterfly in 3 seconds. So this is case 1 or case 2? Arpit, is this case 1 or case 2? Anna, is this case 1 or this is case 1, na? So this is blowing in the medium, right? So the butterfly is in the medium. Okay. Right. So case 1 was the wind problem or the river problem. As soon as you get the river or the wind, just remember that you have to apply the resultant formula, right? Understood? Okay. So yes. So let's just draw the directions first. So this is what? This is east, west, north, south, right? So a butterfly is flying with a velocity of 4√2 meter per second in northeast direction. So northeast direction will be what? This, right? So in this direction, right? And this is 45 degrees. Understood? So this is what? The butterfly. Okay. And wind is slowly blowing at 1 meter per second from north to south. So what is the direction of the wind? Anna, what is the direction of the wind? How do I plot the direction of the wind from this point? Iram, how should I draw the point? It's in the I direction, J direction, minus I direction, minus J direction. What should be the direction? Arpit, what should be the direction? So north is here, south is here. So this is north to south, right? So minus J direction. So this is velocity of the wind. Okay. And this is 1 meter per second. So this has two components. Okay. This is not in the X direction or Y direction. So we will use the universal vector theorem or universal vector representation. Right. Right. So now question for you guys. What will be this component? VB is what? 4 root 2 meter per second. The magnitude is this. So the magnitude is 4 root 2 meter per second. What will be this part? Does anyone remember vector? So this is theta. Okay. And this was X and Y, and this was V. So X was what? The X component was this, and the Y component was right. Now you guys remember anything? Did you guys remember? Arpit? Hello? Hiram, am I audible?
Yes, sir.
Okay. So what will be the two components here? So VB will be what? 4 root 2 cos of 45 I hat and 4 root 2 sine of 45 j hat. Right?
Yes, sir.
Right. So this will be what? 4 root 2 by, and this will be what? Right. So this one cancels. So this will be what? 4I plus 4G. And velocity of wind is what?
Minus J.
Right, right. Okay, so the net velocity that we have, that we were saying was what? Right. So this will be what? 4I plus 4J minus J. So this will be what? 4I plus 3J. Okay. So V net will be what? V net will be what? Magnitude of V net will be
12 square plus 9. 12 plus
which is right. So we have calculated the resultant velocity. Okay. And in this question, they are asking about the displacement, right? So we know the velocity, which is 5 meter per second. We know the time, 3 seconds. So what will be the displacement? Will be velocity into time, right? So 5 into 3, 15 meter per second. Any doubt?
No, sir.
Okay. Now, since no one is responding, so let's just do homeworks. This one is so okay. So this one is for your homework, right? Is that okay with you guys? Please,
Yes.
please,
Yes,
please
sir.
try. Please try this question. Okay. Now let's just move on to this question, and then we will talk about the rain problem. Okay. So the speed of boat and river. So same, boat and river, case 1, right? Case 1, we have to calculate the resultant. So the speed of a boat is 5 kilometers per hour, right? And it crosses a river along the shortest possible path, right? So this is the river. It crosses like this. And the speed in normal water is this, right? Understood? So this is the speed, this is V net, and this is the velocity of the river. Okay. Now it crosses a river of width 1 kilometer. So this distance is given 1 kilometer. Okay. And it is crossing this with what? 15 minutes. Okay. So what will be the speed here? So distance is given. It is 1 kilometer. And time is given. Right. 15 minutes, which means 15 by 60 or 1 by 4. 1 by 4 hours. Okay. So the velocity will be what? This will be 1 upon 1 by 4. So this will be what? 4 kilometer per hour. So we have calculated V net. Right. Any doubt?
No, sir.
So this is 5, this is 4. This will be what? Remember the triangle. Direct answer.
3.
Right. So 3 kilometer per hour. So this one. Okay. Now let's just. So this is again your homework. Okay. Now let us do the river problem. So one is the river umbrella problem. Okay. The rain is falling like this. Okay, so the rain is falling like this, and the person is moving like this. So let's say the rain is falling 4 kilometers per hour. Okay. And the person is going like this 3 kilometers per hour. Okay. So in what direction he should hold the umbrella? With the vertical line. Okay. So in the rain problem, what do you calculate? Can you guys remember? This is case 1 or case 2?
Case 2.
Yes, case 2. So we calculate subtraction or relative motion, relative velocity. Right. Right. So we
Yes.
want to calculate velocity of rain with respect to man. Okay. So this will be what? VR minus VM. Understood? Any doubt? Any doubt in
No, sir.
No,
that? Okay. So this is VM. So what will be minus VM? Remember, recall the subtraction of vectors. How do you subtract two vectors? So this was A and this was B. To calculate A minus B, we extended this B in the opposite direction, right? And then we calculated the resultant. Remember? Remember that? Heather, Idam, Anna, Arpit, Abhinav.
Yes, sir.
yes, sir.
Yes. So what we will do? Which part we will extend? Which velocity we will extend in the opposite direction? We want to calculate rain minus VM. So this will be extended in the opposite direction, right? Right, na?
Yes, sir.
So extend in this direction. So this is VM minus, right? And now we will calculate the resultant. So this will be so this is VM and this is rain. So this is understood my point? So this is what? Minus VM, okay? And this is VR. So the rain is pouring like this, okay? The rain is pouring like this. The relative velocity of rain is like this. Understood? So in what direction should we hold the umbrella? This one or this one? Which one? P or Q? Arpit, P or Q? Arpit? Arpit? Abhinav, P or Q? Aram, am I not clear to you? Do you guys have any question? Please ask. Yes? P or Q? Anna, P or Q?
P.
Yes, P, right. So you just say P or Q. If you have, if you guys have told Q, then I shouldn't have done anything. Nah? I should have corrected you, or maybe you were right. So just tell me anything. Whatever you find correct, please tell me. Because if you are not responsive, then this gets boring, right? Okay, 540. Am I right?
Yes, sir.
Okay, so in this direction, we should hold the umbrella, right? So in most of the cases, they ask about this angle. Okay, and how do you calculate? So this angle and this angle is equal, right? So let's just say this was minus of 3i. So this is what? 3i. And this is what? Minus of 4j, right? So what was the vector? the corresponding vector was 3i minus 4j, right? So to calculate the angle here, so this was the theta, and so to calculate theta, this is what? 3 and this is 4, right? So tan theta is what? 3 by 4, right? And you guys already know that what is, so this is 3, this is 4, this will be what? 5, right? Right or wrong?
Yes, sir.
Yes. So this is 5, and you know that opposite to 3 is what angle? Remember the right angle triangle. So this was,
37 degree.
yes, so 37 degrees. So theta is 37 degrees. So we should hold the umbrella at 37 degree with the vertical. Understood? Understood this question?
Yes, sir.
Okay. So let's just do some problem based on this. So yes. So when a car is at rest, its driver sees raindrops falling on it vertically, right? And when driving the car with speed v, he sees that the raindrops are coming at an angle 60 degree from the horizontal. On further increasing the speed of the car, this angle changes to 45 degrees. So the value of beta is closed. Okay. So the rain is, the relative motion of the relative velocity of the rain is like this for some time. But when the car starts speeding, okay, and it goes with the velocity or with the speed v, so we see that the raindrops are coming at an angle of 60 degrees. So when the car moves, so this is v velocity, right? So the rain appears to be falling like this, right? So this makes an angle of 60 degrees, right? Okay, and from the horizontal. And from the horizontal, on further increasing the speed of car, 1 plus b beta v. So they have increased the velocity and the rain appears to be falling like this. Okay, so this makes an angle 45 degrees, right? So firstly, we'll have to calculate what? So VRM first. What was it? Anybody? So this is second case 1 or case 2?
Case 2.
Yes, case 2. So we will have to use the relative motion, right?
Yes, sir.
Yes. So first we will calculate what? This one. So let's just use this case. So 60 degree from the horizontal. Okay. So this one, right? And this will be VR minus V of what? The car, right? Right. So,
Yes, sir.
so this is V. Okay. So we will have to take what? The diagram, the effective diagram will be what? So let's just first make the effective diagram. Okay. So this is now velocity of what? The car. Okay. And this angle is what? So this angle is 60, right? And so this angle will be what? 60, right? Right. And this is the ray, right? This is the VRN. Okay. Understood. So did you understand this effective diagram? Did you
Yes.
understand? So in the first part, tan 60 will be what? VR by V car, right? In the first part. Understood?
Yes, sir.
So this is what? Tan 60 is √3. V car is V and this is VR, right? So VR is V by √3. Understood?
Yes, sir.
So, yes. So did I make the angle right? This is 60. Okay. And yes. Right. So V is √3 VR. Right. Understood my point? Any doubt?
No, sir.
Okay. Now the effective vector is what? Now it is making an angle. Now it is making an angle 45 degree. And this is the velocity of the ray. Okay. And this is the velocity changes to this one. So the velocity changes to 1 plus beta and V. Okay. So now what will be tan 45? Tan 45 will be what? VR by 1 plus beta V, right?
Yes,
Right.
sir.
So this will be what? This will be 1. So 1 plus beta V will be what? VR. Okay. Right. And we know that V is what? V is √3R is VR. So this one cancels. Okay. So this is √3 VR is equals to VR. Right. So 1 plus beta is 1 by √3. Right. So 1 by √3 is what? √3 is what? Am I clear to everyone or is there any doubt?
Clear, sir.
Am I clear to everyone?
Yes, sir.
Okay, so did I do any? So this was 30, so this was 30. So this was V. Okay, so I made a mistake. Okay, so let's just rub this part. Just forget what I said earlier. I made a mistake, sorry. Okay, so let's just make a clear diagram. So this is the actual diagram that this is V, right? And rain is making this much angle, right? So this is 60, right? Okay, and this is 60, so this will be what? 30. Okay, and this is 30, this is V minus V, and this is the velocity of rain with respect to man, and this is the velocity of the rain, right? Understood? Did you guys understand?
Yes, sir.
So now tan 30 will be what? Tan 30 will be V by VR. Okay. So this is 1 by root 3. I am taking very a long time to calculate this. So VR is root 3V. Okay. So this is, you get the relation between the rain and the speed of the car. Okay. Now your angle is what? 45. You extend this V in this side because you want to calculate velocity with rain, with respect to rain. So this is your triangle V, and this is 45, and this is rain, right? Now the speed is what? 1 plus beta V. Okay. So tan 45 will be VR by 1 plus beta V. Okay. So this will be 1 plus beta V will be what? Root 3V. So now we will get the correct answer. Root 3. So beta is what? Root 3 minus 1. So this is 1.73 minus 1. So this is 0.73. Understood? Any doubt? Do you guys have any doubt? Because I made a mess out of this question. Heather, Iram, Arpit, do you guys have any doubt? Anna?
No, sir.
Anya? Okay. So you understand, na? This is how the rain was pouring. The resultant was this, because we have to take the opposite of V, right? To calculate the
It's the
rain
biggest-
problem. Sorry? Sorry?
Down to the last.
Iram, did you say anything? Hello? Yes. So as I was saying that you calculate V in the opposite direction, and you calculate the resultant. Okay. So that is how you calculate the angle, and then
Overrated as fuck, in my opinion. I mean.
and then you calculate.
I feel like if you think I'm gonna.
Okay.
That's-
Oh, yes. Okay, so I don't know what is happening with Iram's mic. Uh, Hello. Hello.
Yes, sir.
Hello. Am I audible?
Yes, sir.
Yes. So the next topic is uniform circular motion. Is my video is off or what? Uh, yes. Okay. Yes. So the next topic is uniform circular motion, right? We understood about what? The river problem, the rain problem, and the wind problem. Okay. Now uniform circular motion. So analogous to what your linear motion. So linear motion had what? So in linear motion, you had what? The displacement, right? And you had velocity. And you had what? You had angular acceleration. You had acceleration. A, right? So this was linear. This was linear acceleration, right? Now, when you move to some, you move in a circular path or you rotate with some angle, right? So that is called the rotational motion or the circular motion. Okay, so in your angular motion, you have a different distance, displacement, velocity, and acceleration. So analogous to linear motion, you have angular displacement. And then you have what? Angular velocity. So angular displacement is what? Theta. Angular velocity is what? Omega. And then you have, what happened? Okay, somehow my video is getting disconnected. Okay, so, and then you have what? Angular acceleration. Okay, now, what is an angular displacement? So let's just assume that you are moving in a circle, okay? And this circle has a radius vector r, and you move certain distance. So this is A, and this is point B. And you move from here to here. And you complete some angle or you made some angle with this radius vector. Okay, so this is delta theta. So you made some angular, you covered some angular distance, right? So your delta theta here is the angular displacement. And it is a vector quantity, right? So what will be the direction of this displacement vector? So you recall the Maxwell thumbs rule, right-hand thumb rules. So you point your palm in your A direction, right? And you move your four fingers like this. So the direction that your thumb gives is the direction of the displacement vector, angular displacement vector. right? So the direction of delta theta will be what? It is in the board or going out of the board or going into the board? It will be what? Arpit. What will be the direction of the delta theta vector? Arpit, Abhinav, Haider, Hiram, Anna. What will be the direction? It will be inward or outward?
Outward.
Yes, outward, right. So let's just recall the arrow. So the arrow is like this, right? And if you see this arrow from the front, what you will see? This arrow is coming at you, right? So this arrow will be like this, right? And when you see this arrow going away from you, so from behind, it will appear like this, right? So this is what? This is outward and this is inward. Did you understand this analogy?
Yes, sir.
So this will be what? This direction. Delta theta will be this direction. Understood? So to calculate, to relate this delta theta with the linear displacement, can you guys recall the property of the circle or the parallax method? So this distance is not this arc one, this straight line is the linear displacement, dl vector, right? So when you recall the parallax method, we recall that this theta and this r and this l were related. So what was the theta? Can you recall, Hiram? In the parallax method or this relation? When your theta is small and this is your length. So do you guys remember this relation? Not. So I assume not. So this is how you relate theta with this distance. So from here, what will be your theta? So your delta theta will be what? Delta L by R. Okay, R hat. So this is how, so your angular displacement is related with this linear displacement. Okay, so your delta L is what? Delta theta cross R. And when you calculate the magnitude, so this will be what? Delta theta into R sine theta and your n hat. Okay, so when your theta is 90, so your delta L will be what? Theta into R. Understood? This is not the dot product. This is just the multiple. Understood about the angular displacement and the linear displacement?
Yes, sir.
Yes, sir.
Now you have what? The angular velocity. So similarly, your angular velocity is represented by what? Omega, and this is related with linear velocity. So your linear velocity v is omega cross r. Okay. And the magnitude of it is what? V is omega r. Just remember this. Okay. So this angular velocity, just like your linear velocity, is what? Displacement. Similarly, your angular velocity is what? So what is your angular displacement? Angular displacement is delta theta by delta t, right? So this is the average angular velocity. Do you guys recall that in the velocity part, I did two parts. One was the average and one was the what? Instantaneous, right? So what will be the instantaneous velocity? What will be the instantaneous angular velocity? This will be what? Anna, this will be what? So this is what? Delta x by delta t. This is dx by dt. So can you recall this instantaneous angular velocity will be what? From this analogy. Arpit. This will be d theta by dt, right?
Yes, sir.
Yes. So now, similarly, we have angular acceleration. Angular acceleration. But we are doing only the uniform circular motion. So for uniform circular motion, your velocity is constant. So your angular acceleration is 0, right? For uniform circular motion. Okay. Now, what is uniform circular motion? So uniform So for uniform circular motion, your linear velocity is constant. Okay. Your direction of linear velocity is changing. Right. Your angular velocity is constant. Okay. And your angular direction is constant. The direction of the angular velocity is constant. So that is what you call uniform circular motion, right? And in uniform circular motion, you experiences an acceleration. So let's say a body is moving like this, and this is the origin or the center of this radius, this circle. Okay, and this is the radius. So towards the radius, this body will feel an acceleration. Okay, towards the radius. So this is called the centripetal acceleration. And the value of centripetal acceleration is equal to v square by r. Okay. And you know that V is related with omega as omega R. So this is omega R square by R. So this is omega square R square by R. So this is omega R, right? Okay. Understood?
Yes, sir.
So this was about the uniform circular motion. We will do the question on the basis of this in the next class. So I wanted to do some question on the basis of this uniform circular motion. This I wanted to do. This one, the next one. So these I will do in the next class. Okay. So I will start from here. Any doubt, any question up to this point?
No, sir.
Okay, so let's meet tomorrow and we'll start from there. Bye everyone.